Hi, Assalamualaikum. Today we will be presenting our academic visit to MAB Kargo Sdn Bhd as part of our group project for BTM454. We are from class NBTM3B and this presentation is prepared for Sahabil bin Zakaria. Let me introduce our team member, me and myself, Nur Azli binti Abdul Karim, and here we have Nur Suzila binti Muhammad Nasir, Mashita binti Muhammad Kasim, Nur Shamimi binti Aziz, and the last one, Nur Shariza binti Johari.
Introduction. Company background. MAB Kargo Sdn Bhd, also known as MAS Kargo, is the air cargo and logistics subsidiary of Malaysia Aviation Group. It serves as Malaysia Airline dedicated cargo division, supporting the national carriers logistic and freight operation. MAS Kargo operates using dedicated freighter aircraft as well as cargo capacity on passenger flights. This operating model allows the company to efficiently handle diverse types of cargo, including commercial goods, perishables, pharmaceuticals, and express shipment across nearly 100 global destinations. Relevance to technology management. MAS Kargo is highly relevant to technology management because its cargo operations rely heavily on digital systems and automated processes. Technologies such as cargo management systems and warehouse automation enable real-time coordination with airlines, freight forwarders, and custom authorities. Effective management of these technologies is essential to ensure operational efficiency, regulatory compliance, and competitiveness in the highly regulated air cargo industry.
Hi, so next I will explain about technology management practice used by MAB Kargo, focusing on information technology management. First, MAB Kargo uses a leverage IT structure. This means they work closely with an on-site vendor, which is Lodge Industry, so for fast troubleshooting and maintenance. Because of this collaboration, system problem can be solved quickly and downtime can be reduced. Next is Technoware. Technoware is referred to the physical hardware used in the warehouse. So at MAB Kargo, this includes the 16-level box storage system as well as large automated machines such as elevated transfer vehicle or ETVs and turntable vehicle TVV. So this machine help move and store cargo efficiently with minimal manual work. So the third component is Infoware. So Infoware is the core software system that control warehouse operations. So MAB Kargo uses a warehouse integrated system which act as the brain of the warehouse. So this system ensure that all cargo movement are tracked, coordinated, and recorded accurately. So lastly, MAB Kargo uses a real-time monitoring. So they apply human-machine interface, HMI, alerts, and CCTV visual diagnostics. So to monitor operations continuously. So this tool help detect error early, reduce machine downtime, and improve overall operational safety. Okay, so the next is operational security and cybersecurity at MAB Kargo. First is a comprehensive surveillance. So the warehouse is monitored using a large number of CCTV cameras. So this allows continuous monitoring of cargo movement and improve overall security. Second is an advanced screening. MAB Kargo uses an X-ray machine and explosive trace detection system to screen cargo. So this system helps ensure cargo safety and comply with international aviation security standard. So the last one is a unified technology. So all security systems are connected under one integrated network. So this allows a real-time data sharing, faster response to the incident, and better control of operations. Okay, for this part, I will explain about innovation management that MAB Kargo applies, which is they are apply both radical and incremental innovation. First, radical innovation can be seen through the Cargo Warehouse Integrated System or CWIS that integrates automates machine with the real-time information system and changes cargo handling from manual decision making to system-driven operation. So second is incremental innovation is applied through simulation and logic optimization. So before making changes in the real time, warehouse, MAB Kargo uses simulation to test cargo movement and system logic. So this helps improve efficiency, reduce congestion, and avoid operational risks. Okay, so the last topic from me is about strategic technology planning at MAB Cargo. So strategic technology planning means managing technology to support long-term business goals. So at MAB Cargo, so this can be seen through a dedicated technology expert team. So this team manage a critical system like CWIS and warehouse automation and ensure technology decision align with operational needs. So MAB Cargo also focus on technology lifecycle management instead of a replacing system frequently. So they extend the life of existing technology through upgrades, such as in 2011 and 2014. So at the same time, MAB Cargo also realized that future risk of obsolescence. This is why they have introduced the 2026 this year transformation initiative. So to prepare for future operational and technological changes.
Identification of challenges and opportunities. We have identified three critical challenges. First challenge is the financial impact of vendor lock-in a leveraged IT structure. And maybe Kargo currently adopt a leveraged IT structure. This means their internal IT team focus only on governance while actual execution is outsourced. The problem why this ensure high system availability, it has created a vendor lock-in with legal industry. They rely entirely on their proprietary TVV and ETV technologies. The result because of this reliance, and maybe Kargo are subject to monopolistic pricing for maintenance. They are financially dependent on a single vendor, which keeps the operational costs high despite good performance. Second challenge is brainware competency gap in physical operation. MAB Cargo have made substantial investment in technology machine and infoware system like Seaweed. However, the problem there is a bottleneck in their brainware, especially a gap between senior and junior staff. The report highlights that while the system display accurate data, junior staff often lack the special and experiential knowledge to interpret it. The result, this leads to a tech-human mismatch. The staff struggle to translate digital information into effective physical action, meaning they aren't fully utilizing the system potential. The challenge is technoware obsolescence and sensor limitation. MAB Cargo last major system upgrade was back in 2014. The problem consequently, MAB Cargo sensing technology is lagging. They are using legacy sensor with limited field of view, creating sensor blind spot. The result, unlike modern systems that use AI vision or 360-degree lidar, the machine may fail to detect obstacles outside their range. This increases the risk of accident and prevent them from achieving zero collision operation. Next, we have identified three strategic opportunities that directly address their internal constraint. First opportunity is leveraging historical data for cost optimization. MAB Cargo have accumulated 26 years of operational data dating back to the system inception in 1998. The strategy opportunity here is to shift from a costly reactive approach to predictive maintenance. The benefit by analyzing past failure pattern, we can focus exactly when components will malfunction. This allows us to schedule repairs during standard windows, significantly reducing emergency costs and the financial burden of vendor lock-in. Second opportunity is workforce capability enhancement through digital guidance. As mentioned in the challenges, is junior staff struggle to translate digital data into physical action. The strategy, we can integrate digital navigation tools that visualize system data directly in the physical workspace. The benefit, the guide staff directly to fault points or cargo location without needing years of experience. It effectively shortens the learning curve and ensure performance is driven by system efficiency, not just individual seniority. Third opportunity is enhancement of operational efficiency and productivity. Currently, the machines are speed restricted, throttlered to mitigate risk caused by sensor blind spot. The strategy, by upgrading to sensitive modern sensor, we can remove these safety bottlenecks. The benefit, this allow MAB Cargo to safely unlock the full speed potential of its machinery. The result is faster turnaround times and higher productivity without compromising on safety.
This section focuses on the integration of theory and practice in MAB Cargo. It highlights how key concepts in technology management are applied in real operational settings. The discussion is organized into three main areas: information technology management, strategic technology planning, and innovation management, which will be explained further in the next slides.
The integration of theory and practice under information technology management at MAB Cargo. First, for leverage IT structure and cybersecurity, the theory is based on the CIA triad: confidentiality, integrity, and availability, supported by security-conscious IT governance. In practice, cybersecurity for warehouse automation is outsourced to LawDG, which complies with ISO 27001, while internal IT focuses on corporate system. This integration allows MAB Kargo to reduce high fixed costs by converting them into operational expenditure while ensuring high system availability. Next, technology component and life cycle. The theory emphasizes the integration of technoware and infoware as well as the technology S-curve. In practice, automate machines such as ETVs, TVVs, and SRMs are controlled by CWIS with major system upgrade carried out over time and further transformation plan for 2026. By coordinating system well and upgrading regularly, the company avoids outdated technology and maintains efficiency. Next, strategic technology planning and innovation management. For strategic technology alignment, the theory emphasizes aligning technology decisions with long-term organizational goals and effective lifecycle management. In practice, MAB Kargo has a dedicated technology expert team that governs CWIS and warehouse automation while extending the life cycle of existing systems. This integration allowed the company to balance the use of major systems with further transformation, ensuring business continuity and competitiveness. And the last but not least, for integration of innovation, the theory distinguishes between radical and incremental process innovation. In practice, CWIS represents a radical innovation, while simulation-based optimization is used as incremental improvement. Overall, this combination enables major operational transformation with controlled risk and continuous performance improvement.
Next is recommendation. First, integration of AI-driven predictive analysis for historical data. MAB Kargo should leverage its 26 operational data achieved by integrating AI element to analyze specific technical component failure pattern. By utilizing AI to process data accumulated since 1998, the company can transition from costly reactive maintenance to a strategic predictive maintenance approach. This move allows for accurate forecasting of component lifespan, enable repair to be scheduled in advance to avoid premium rate for emergency vendor call-outs and reducing the financial burden of extreme vendor clock-in. Second, adoption of AR smart classes for enhanced staff navigation to overcome the limitation of junior brainware and accelerate the onboarding of new staff. The implementation of augmented reality AR smart glasses is highly recommended, as this technology has become a global standard in modern warehousing. AR technology allows digital navigation layer to be overlaid directly onto the physical environment, visually guiding staff to route location or specific cargo without the need for manual searching. This benefit enables inexperienced personnel to perform as efficiently as senior experts, reduce human error in data interpretation, and ensure the continuous flow of warehouse operation. Third, systematic upgrading to 360 degrees LiDAR sensor technology to eliminate physical accident risk stemming from 2014 era sensor technology. MAB Kargo must upgrading its TVV and ETV system with modern LiDAR sensor featuring 360-degree sensitivity. The implementation of modern LiDAR sensor aims to eliminate sensor dead zone or blind spot that frequently cause collision at the corner or side of the machine. With a higher and more comprehensive level of sensitivity, this machine can navigate the warehouse floor with greater confidence and precision, allowing for increased operational speed, safety without compromising the physical safety of worker or cargo. In conclusion of our academic visit, MAB Kargo is a great example of how to manage technology efficiently. The company is successful because it doesn't not just rely on having expensive machine or big robot, but our analysis of MAB Kargo show that the true success comes from a comprehensive approach. This means looking at a big picture and making sure that machine, software, program, and people work together smoothly. The most important lesson from this project is that a company cannot rely on hardware alone. MAB Kargo used the four key parts, which are technology, hardware, software, brainwave, and organization rule. We saw that their big machine, such as the storage retrieval machine (SRM) and elevator transfer vehicle (ETV), are useless without the brainware of the operation. This proved that the physical strength in a warehouse must always be guided by digital to be effective. One of the most important things that we found from our visit is that humans play a big role and are still important even in a fully automated warehouse. While the machines are doing the heavy lifting and high-speed storage, the human team and the control room is responsible for making the final safety decision. Additionally, even though the MAB Cargo was built in 1998, they have kept it running well by constantly upgrading the technology year by year, starting from 2011 and 2014. Now, they are even planning for the 2026 transformation. The MAB Cargo proved that a business competitive is achieved through the acquisition of approach technologies combined with continued upgrading and improvement through the technology life cycle. That's all from us, and thank you.